What we're going to do now is we're going to do a couple of examples of converting from standard form and then to intercept form and finding key values within the parabola. So obviously what we have right here is a parabola, and we've got an equation for one, and this equation happens to be in vertex form. So in vertex form of the parabola, we can actually find out a bunch of information. Remember, with the vertex form of a parabola, we can always identify what our A, H, and K values are. That's going back to even the first quadratic unit. And so in this case, our A value, because there isn't one written, the A value is actually positive 1. The H value is negative 3. It's the opposite of what we have here in the brackets. And then my K value is going to be negative 9. So I know, here, let me try that again, negative 9. So I know that my vertex is always the same as my HK value. So my vertex in this particular equation is going to be negative 3, negative 9. My axis of symmetry happens when x is equal to h. So the equation of the axis of symmetry is x is equal to to negative 3. My direction of opening, I know my A value is positive 1. So my direction of opening is going to be up. Is it going to be a minimum or maximum value? Well, since the parabola is opening up, it's going to end up being a minimum value. And so my minimum or maximum value, also known as my optimum value, that's equal to k. So whatever my k value is, so that's going to equal negative 9. Okay, and then my step is positive 1. Okay, so I just actually need to figure out what my y-intercept and what my zeros are. So in order to do that, I actually have to convert from vertex form into standard form. So that's what we're going to do first. And again, we have to recognize that we have a binomial here, and so we need to actually expand out this binomial to get it into standard form. So if we do that, we end up with y is equal to x plus 3 times x plus 3 all minus 9. So then I'm going to use my FOIL pattern, and I'm going to do x times x, x times 3, 3 times x, and 3 times 3. So that's going to leave me with x squared plus 3x plus 3x plus 9, all minus 9. And so I'm going to go through, and that's going to be, I'm going to collect my like terms. That can give me x squared plus 6x plus 9 minus 9. And so this is going to end up being x squared plus 6x. Okay? And I'm going to put in plus 0 at the end to make sure that it's actually a trinomial. So this here, this is now in standard form. Okay? And so based on this equation, we can see that the c value is going to be 0. So our y-intercept is actually at 0. Okay? And so the next thing that we need to work with, okay, so I'm going to do this. So our y-intercept is 0. Okay? The next thing that we want to do is we want to convert from standard form into factored form. And so I'm just going to quickly do a line break there to indicate that these are different equations. Okay. Okay. So now I need to go through and I actually need to factor out the standard form of this equation. So the standard form of this equation is going to be what we have up here. We've got x squared plus 6x plus 0. So if I factor that, I'm looking for two numbers that multiply to 0, but that add to positive 6. So that means that my factored form is going to be x plus 0 and x plus 6. Okay? And so if those are if that's my factored form of the equation, my zeros are going to be at 0 and at -6. Okay, and so if I'm looking for my zeros will be at 0 and -6. Okay. So now I've determined what those are going to be, and if I want to just quickly verify my axis of symmetry, I could do that off to the side. I know that my axis of symmetry is going to be 0 plus -6 all divided by 2. That's going to get me -6 divided by 2. That's going to give me -3. So when x is equal to -3, that's when I've got my vertex. And in fact, we've already determined that because it gives us that value up here in the vertex. So we've now figured out all the necessary components for converting this particular equation and getting all the information we can out of it from the three forms of the parabola.